Vanakkam. Welcome to this video on biomedical instruments. In one of the previous videos, we discussed about piezoelectric sensors. One topic that we missed to discuss is the idea of corner frequency or cutoff frequency in piezoelectric sensors. Note that we can actually model piezoelectric sensors as a charge source, and that is what it is it not? So when I apply a load, it generates a charge. So that means I can model the piezoelectric sensor itself as a charge source that is in parallel with some internal capacitor with some capacitance C. So this is the model of the piezoelectric sensor. Usually, the electronics that is used to interface it with the rest of the system can be considered as a resistance. So this is essentially an RC circuit. This essentially creates a high pass filter. This is an RC circuit that acts as a high pass filter. We discussed this in one of the previous videos, and I even asked you to check why is this a high pass filter and how would you use an RC circuit to design a low pass filter. I asked this in one of the previous videos. So this is what happens in this case. This RC circuit acts as a high pass filter. And because for piezo systems, we use a high input impedance amplifier electronics to process the data, we need to compute the corner frequency or the cutoff frequency, and when you do that, you need to find the effective resistance. So there are two resistances: the resistance of the electronics or the interface system, and the input impedance. So you need to find the effective resistance, and this corner frequency, that is the lower cutoff frequency, the low corner frequency, is FC is 1 divided by 2 pi RC. I will attempt to write. I will write it only using the mouse. That is 1 divided by 2 times pi times capital R and capital C. Now, what is R here? R is it looks like Z, so I'll make it 2 here. What is R here? R here is the effective resistance, okay, which you need to compute, and then compute the lower cutoff frequency. This is how we can find the corner frequency or the lower cutoff frequency. Remember, this is going to act as a high pass filter. That means frequencies below this particular cutoff frequency will not be passed or will be attenuated. That is something that you need to remember. Okay. With this, we will end this mini lecture on this topic. We will continue our discussion on electrochemical sensors in the next video. Thank you very much for your attention.